Hello students, welcome at Educare. This is Bihani and we will continue in today's math section about the topic called derivatives, an important part of calculus. In the last two sections we have seen first what is meant by differentiation or derivatives and second rules of derivatives. Today we will see a very important concept in derivatives, that is about the composite function, how to get their derivatives by a rule called chain rule. First to know what is meant by composite function. Now see here example, if you have y equal to sin x, then do you know derivative of this sin x is cos x. But what about if y is equal to sin square x, which means it is sin x bracket square? Such function is composite function. What is composite function? If y is function of u and u is function of x, then y is called composite function of x. Here how to understand? Here in the sin square x it is a composite function. To understand that, see here, if you take y equal to sin square x, which means sin x bracket square, if you let sin x equal to u, then y will be u square, but here u is sin x. So here y is function of u and u is function of x. Y depends on u, u depends on sin x. U depends on x, I mean. U depends on x, y depends on u. That means y is function of u is function of x, and such combination then called as y is a composite function of x. So that is the meaning of composite function. Now we will see the chain rule, how to find the derivative of such composite function using a chain rule. What is chain rule? Just we have seen, if y is function of u and u is function of x, then y is called as composite function of x. To get the derivatives of such composite function, we have such formula that is called a chain rule. Dy by dx equal to dy by du into du by dx. Although without use of this formula, a student by practice can direct write the derivative of composite function also. I will take by both ways, and at least we will take two examples to understand this concept called derivatives of composite function. We deal with first example same. Suppose you want to get the derivative of sin square x. Now do you know y equal to sin square x means that can be written as sin x bracket square. So we let here u equal to sin x. Therefore derivative of u, that is du by dx, will be cos x. Correct? So that is du by dx. And when you take y equal to, u equal to sin x, that means you are getting y equal to from this u square, and this derivative with respect to u will be dy by du, that is equal to derivative of u square, which means 2u. But now you put the value of u, which is sin x, so that it will be 2 sin x. And now you put the values of du by dx, which is cos x, and dy by du, which is 2 sin x, in that chain rule. So dy by du value put here and du by dx value put here, so that dy by dx will be, that I am writing here, dy by dx equal to dy by du, that is 2 sin x, and into du by dx, that is cos x. So that will come 2 sin x cos x. That is how to use the chain rule. Now same example you can write direct also by understanding something like this. What we have given to find derivative of y equal to sin square x, that means it is as same as sin x bracket square. Now if you want to differentiate, then to get derivative that called as differentiate with respect to x, then we have derivative of y dy by dx equal to get the derivative of sin square x, suppose this bracket is x, then it will look like x square. What is derivative of x square? It is 2x, but here it is not x, instead of x it is sin x, hence it is 2 sin x and into derivative of sin x, which is cos x. That is how to get the derivative by chain rule, but directly written without writing u and without writing that chain rule u's. We'll take one more example. Suppose you have y equal to square root of, to find the derivative of that second example, suppose y equal to square root of log x, and if it is asked to find the derivative of that log x, root log x, to get the derivative it is y equal to root log x. Suppose it is not log x, suppose it is only x, then to get the derivative dy by dx will be, do you know derivative of root x is 1 upon 2 root x? So here 1 upon 2 root x, but actually it is not x, it is log x, so it will be 2 root log x into derivative of log x, which is 1 upon x, and then the derivative can be written resultant as 1 upon x root log x. That is how to use the chain rule to get the derivatives of composite function, or how to find the derivatives of composite function. And if you like this video, share this video with your friends, subscribe to our channel, press the bell button icon to get our latest videos information. Thanks.